Hello, everybody. Welcome to second webinar of summer series, Design and Check of Reinforced Concrete Beam in IDEA StatiCa from AxisVM. My name is Petra Komarkova, and I'm going to present today's webinar. I'm here alone because the summer series webinars are focused on one problem, and they are short. Before we get to the actual content, just a quick reminder, if you have any question, please type in them into question pane and I will try to answer them at the end of the webinar or after the webinar via email. So today's topic is focused on a reinforced concrete beam from AxisVM to IDEA StatiCa. Imagine this example. We deal with reinforced concrete cast in situ hall. The part of the hall is made of steel. The second part is made of concrete. We are going to focus on concrete part and especially this critical member. It is a normal, regular concrete beam of a rectangular cross section. But what if the future using of building requires an opening or two openings at the supporting area and hanging at the midspan? How would you analyze and check such a member, such a beam? It is a non-standard beam, and I would like to offer you a workflow, how I would like to work with IDEA StatiCa and AxisVM link. Before we go to practical example, let me do a small recap of the BIM workflow. So step number one is in software AxisVM. So we have a global model, we have results available after the global analysis, and we are able to find the critical member. And this critical member will be exported to IDEA StatiCa Beam. IDEA StatiCa Beam is an application which enables design and code check of beams made of reinforced or pre-stressed concrete. Beams can be checked or it is suitable for beams which are in so-called B regions where classical beam theory can be applied. But for these purposes, we are not going to deal with this because our whole beam is treated like a D region. That's why we need to export this beam to IDEA StatiCa detail. So IDEA StatiCa Beam application serves here as a middle application between AxisVM and IDEA StatiCa detail, where we modify the topology and do the reinforcement design and of course analysis and checks. And in the last step, we are going to create bill of material and final report. So enough of talking and let's jump to the software. So I'm going to switch off my camera and switch to AxisVM. So I hope you can see our model. It is a whole type building and I have already calculated the whole structure. I have the results, and now I can export this beam. This is our critical member to IDEA StatiCa beam. How to do it? So you select the beam, go to plugins, choose IDEA StatiCa beam. Code check manager will open. You select the code. You can select Swiss code, or in this case, it will be Eurocode. Then we can click next. The data are loading. In this step, it is necessary to define boundary conditions. So since it is a part of concrete frame, I'm going to fix both ends of the beam. So all displacement and rotations are fixed. Then click next. Here we specify the type of beam. It is cast in situ concrete beam. In this step, if you wish, you can define national annex. Let's stay with general Eurocode, design working life, and we can create load cases or generate them. We will generate a self-weight according to cross-section, and these two loads will be set to 0 values because in the next step we are going to export this live load and concentrated load, which was defined here in AxisVM. So I click Add All and click Finish. So in a minute, IDEA StatiCa beam will open, and we can check how the geometry and loads was imported. So this is our beam. I click to second view, and as first, let's go to load cases and see the list of load cases. So the first one is self-weight. It will be calculated based on cross-section. The second is live load. It is a uniform load which was defined in AxisVM. It has LG2 load group, and the third load case represents concentrated load, and there is necessary to switch it to LG3 because it is another type of variable load. I will go to variable load groups and check if these factors are correct. So I can see that LG3 is different type of variable load. So I will define these factors for generating the combination. Then I would like to show you user-defined forces. Under this button, we can check how the internal forces were imported from Axis to IDEA StatiCa. So in a minute, we will check out the distribution of internal forces along the beam. It might take a while, but I'm sure that eventually we got the results. So, for example, here we have load case concentrated load. I will click on extreme on member, so I can see the extreme values, maximum and minimum of bending moment for concentrated load. If I want to see different internal forces, for example, shear force, this is the distribution of shear forces for concentrated load. So these internal forces were calculated in Axis, and we imported them to IDEA StatiCa. As last, we are going to go to combinations and set the content of the combination. So here you can see that there are combinations prepared for ULS and SLS checks. And under the description column, we can see that there is only self-weight load case. So we need to go to Load Combinations Manager and add the variable load cases to each combination. So I will do it just like this. Click on the combination and then this arrow and confirm OK. And now I got the load cases into combinations and they will be evaluated according to code. Then we click on Calculate and in a minute or second, we've got the internal forces here in IDEA StatiCa beam. So right now we are checking the envelope for ultimate limit state for bending moments. Here we have shear forces. If I want to look at the, for example, characteristic combination, I just switch it here and here I can choose between the or among the internal forces. Then we click to reinforcement, and since we won't deal with classical beam theory, we won't check it here. We are going to this button Export Detail and export the whole beam to IDEA StatiCa detail. So if you remember the workflow which I was showing at the beginning, this is the step or end of the step number 2, and we are entering the third step. So this is the, let's say, another wizard which will help me to configure the member or the beam in this case. We are going to import the whole design member, but as you can see, we can import just the part of the beam. Then I click Next. User can decide whether he or she want to import load cases or combinations. I will go for combinations. So from this list, I can choose the ones which are the extreme or produce the maximum or minimum internal forces. So for ULS combination, it will be combination number 1 with this description. Then we have characteristic combination and quasi-permanent. So I will click Add. This combination will be imported to detail and click Finish. So right now we are getting to step number 3. Let's say yes. And in a few seconds, IDEA StatiCa detail will open. Okay. Let's try it again. Probably this was project which I have created yesterday. So let's export the beam again. Combination. Add, finish. And right now I should get the right project in IDEA StatiCa detail. I will go for no. Yes. So this is the let's say, empty project, we imported the geometry of the beam, and we will proceed according to the workflow. So as the first step, we are going to settings and set the right concrete cover. Here it is some default value, or maybe it was defined in Axis. I will redefine it to 25 millimeters. Then I go to geometry, and first I will delete these supports and add line supports. It is a fixed end. It will act in compression and tension, so I uncheck this button, and it is necessary to define the right edge of the beam. Then I copy this support and define left. So boundary conditions are defined, and now it is time for creating the opening. So we will deal with circular opening. The diameter will be 55 centimeters, and then using master point and insert point, and the right position, I created or placed the opening into desired position. Then I copy this opening and change these points and set this distance to negative 0.6, and that's how I quickly place the second opening. As the last entity will be hanging load, it will be in this case load transfer devices. Let's define the dimensions. Diameter is 20 millimeters. So this is, I will switch to real 3D view. So this is the final topology of our analyzed beam. You can see how fast we created the topology, quite complicated, and then we can proceed to the next step. And the next step is definition of loads. Since we have used this beam link with Axis and IDEA StatiCa beam, we don't have to define the load cases here. We can just check if the values, I will click to model view, if the values are correct. So these load cases were calculated based on internal forces in IDEA StatiCa beam. So the derivation of these internal forces caused these load effects. In concentrated load, we go to load impulses and set the transmitting device to hanging. So then we can apply this huge force right to hanging. Then you go to load cases and combinations tab. And if we click on combination and this blue pen, we can check the coefficients or the factors, partial factors of the load cases. So you can see that the description is just according to IDEA StatiCa beam. So everything is defined, and you don't have to care of loads anymore. In the next step, we are going to design the reinforcement. So as you can see, there is no reinforcement defined, and I decided to show you or demonstrate how to apply a reinforcement template. So I will go to templates and click apply. I will choose the template. So I believe that's this one. Click apply. And you can see that reinforcement layout is defined. We have bottom and upper reinforcement, reinforcement around openings, and of course the stirrups. You can modify the numbers and diameters, of course, but for these purposes, I'm satisfied with this reinforcement layout and I would like to process further. So then you go to check and calculate or analyze the whole beam by clicking on check button. Since I would like to save the time, I will open calculated project. So we've got the results. And the first step, summary, you can see the most critical places regarding concrete and reinforcement. You can see the cracks distribution, etc. In the left bottom part, we can see immediately the utilization of the concrete and reinforcement and anchorage in ultimate limit state and of course in serviceability limit states. So if we look at the concrete and reinforcement, we can see that there is room for optimizing the number of reinforcing bars or maybe reducing the diameters of the reinforcement. For these purposes, I won't optimize and I would like to look at the results very briefly. And since we don't have much time left. So second tab, it's called strength. And here it is a strength check of concrete and reinforcement. So first there is a concrete check. You can see check of the stress in concrete in compression. If we want to see actual value of stress of concrete in compression, I clicked on this button sigma C. So the concentration of the stress appearing in the vicinity of the openings. If I click on this row reinforcement, this table open and we can see the most utilized reinforcing bars. In this case, those are stirrups. Here in this main window, you can see the stress in reinforcement. Blue is tension, red is compression. I can maybe mention that the hanging is checked only the part which is in concrete. The part which is overhanging is not checked. Then I would like to show you the deflection of the beam. So in this deflection tab, we can look at the deformed shape of the beam. We can see the maximum deflection, including creep at the midspan of the beam. As you can see, the deflection is too small and this beam is probably very stiff. So let's leave the results and go to bill of material. By this, we are getting to step number 4 of the BIM workflow. And if you are happy or satisfied with the project, you can generate bill of material and report of this whole analysis. As you can see, there is list of reinforcing bars, their shapes, and of course, user can export this to DXF file and create the detailing drawing. And as the last, as I have mentioned, you can generate the report. It can be brief or detailed. You can customize it and include what you actually need to have it in the report. So this is the preview of the report. So this is the end of the practical, very short but practical example. And let me go back to presentation. And I believe now is the time for your questions. So let me check the list of the questions. So first question is, which global FE software is supported except AxisVM? I will show you, or maybe name or maybe it will be better to show it on our website. So this is our website, and we have this BIM links part, and you can see the list of the finite elements softwares which are linked to IDEA StatiCa. So it might differ, depends if you deal with steel applications or concrete applications, but since we have concrete webinars, so I will tell you that we are linked to, for example, robot structural analysis, SIA engineer, MIDAS civil, but it is linked to specific countries. Then AxisVM, of course, and advanced design. I hope I didn't miss anything. So thank you for the question. Second question is about reinforcement. Does IDEA StatiCa care of detailing? So application IDEA StatiCa Beam checks detailing, but IDEA StatiCa Detail does not check it, and user need to care of it. Then we have another question. How long does it take approximately take to calculate this beam in IDEA StatiCa Detail? Such a beam, it takes, let's say, I think it's up to 5 minutes, but I can measure it. Then we have another question. How does work robot structural analysis BIM and IDEA StatiCa? So robot and IDEA StatiCa works on the same principle as Axis. So you can select the critical member, export the member to IDEA StatiCa Beam, and continue in IDEA StatiCa Beam. Or if it is more complicated topology with openings and I don't know, depth ends, then it is recommended to go to IDEA StatiCa Detail, just like I showed you. And then we have another question. How can I create reinforcement template in IDEA StatiCa Detail? So it will be better to demonstrate it. So let me switch the presentation. I hope you can see the IDEA StatiCa Detail. And the user needs to go to reinforcement. So I clicked on reinforcement, and I showed you how to apply it. So just next to the button apply is create. So if, let's say, this is my reinforcement layout and I would like to save this as template. So I go to create. This template manager will open. You just name it. So for example, reinforcement, I don't know, 1. You can add a description if you wish. Click OK. And you can simply apply it. Here it is my reinforcement template. This template is saved to your PC. If you wish to share it with your colleague, you need to export this reinforcement template. It is done via Manager, Template Manager. So if you click on it, you set the right filter. You will see the templates which are available, or let's say saved in your PC. I just created this reinforcement template, and you click export. You name it. It has a EXP extension. Save it, close, and for example, your colleague on his or her computer, click again Manager, import, find the exported reinforcement, open it, and get it to his or her computer. And then he can see, you can see that you can simply apply the reinforcement just like I did it at the practical example. So I'm sorry, but we are running out of the time. So the rest of the questions will be answered via email. I'm glad that you are interested in this topic. So thank you very much for the questions. We are almost finishing the webinar. So please, after the webinar, fill in the short survey where you can express your opinions, practical experiments, or ideas on a topic or topics on our next webinars. The recording of this webinar will be available on our website and YouTube channel. If you are new in IDEA StatiCa community, don't hesitate and get a trial and test it on your own. And as the last, I would like to invite you to our new support center, where you can find a lot of materials, a lot of tutorials, verification articles, and videos if you want to educate in IDEA StatiCa. And besides that, you will find among the tutorials very similar project, very similar to this practical example, which I show you on this webinar. Let me invite you to our next webinars from summer series. In a week, there will be webinar focused on footing connections. So this topic will be or might be interesting for steel structural engineers. And if you are a more concrete focused engineer, you can look forward to having another webinar in August, and this the topic of the concrete webinar will be specified in few days. So thank you for your interest. Thank you for joining in the webinar. I'm happy that you were with me today, and I'm looking forward to being with you on our next webinar. So have a great day, have a great summer, and calculate yesterday's estimates.